Okay, in this screencast we're going to look at the product and quotient rule of differentiation, and this is hot on the heels of our work on the chain rule, and before that just setting up for differentiation. And what we're doing right now is we're getting just a whole bunch of differentiation tools together, so that we can just differentiate more and more functions. Now, this section here is about functions that have the product of two functions of x involved, and quotient rule to do with functions that have quotients of x or division of functions of x. So a product rule might be, x squared plus 1 to the power of 7 by x minus 2, this sort of thing. So that's a massive undertaking without the product rule. Quotient rule might be something along the lines of along the lines of a function that looks like that, where you can't do much with it. And we had a look in the previous exercise where we had a denominator with more than one term, and it's difficult. If you've just got one term in the denominator, different story. You don't need to use a product rule for that. You can just split this up, can't you? X squared over x plus 1 over x. We can work that through. Just like we can with a product rule. We don't need the product rule to differentiate that sort of function, because we can expand it and do it that way. It's going to be much quicker. But there's plenty of opportunities for us to use these, and more so once we start looking at the calculus, the differentiation of different types of functions. So when we start to differentiate trig functions, for instance, or or log functions, so log x on x, this sort of stuff. We're going nowhere without our product and quotient rule. So let's learn about these things. Okay, so the product rule firstly, the product rule of differentiation. So what we do is we just firstly identify a u and a v. So our two functions that are being multiplied together, we're going to label them as different functions of x, u and v. So let's have a look at maybe we'll just have a look at an example. So find the derivative of y equals 2x plus 3 lots of this is going to be 4 minus 3x. Now this is an example I was talking about before where we actually don't need a product rule for here. This because we can just expand this out, can't we? And do it that way, and we will do that, and then we'll use the product rule. It's a nice way of verifying, is it not, that it works for us. So this comes to, well, I'm not doing anything yet, I'm just simplifying, minus x plus 12. Now I'm ready to derive. I'd say this is in differentiable form, minus 12x minus 1. That gets me on a derivative. But now let's use the product rule. Now the product rule does this. It takes a function where there's a product of two functions. All right, so we say so now using the product rule, right, which we haven't yet defined, but I'm going to talk to you about it now. Right, so y equals 2x plus 3, 4 minus 3x. Clearly, we've got two functions multiplied together here. So I'm going to let this function here, 2x plus 3, be u, and 4 minus 3x be v. And it'll be the same when we get to the quotient rule, it'll be u over v. So the product rule states this. All right, the product rule states this, that dy dx is equal to u by the derivative of v plus v by the derivative of u. That's it. That is our product rule. Using the product rule, that guy there. Right, so let's use it. U by the derivative of v. Now u is 2x plus 3. 2x plus 3. V dash is the derivative of v, which is minus 3. Right, so that times that. Plus v, which is 4 minus 3x, by the derivative of u, which is 2. Right, now that's derived. Just need to sort it out. Minus 6x, that's minus 9. Plus 8 minus 6x. So we get minus 12x minus 1. Look at that. Minus 12x minus 1, minus 12x minus 1. You beauty. It works. That's the product rule. So I'll leave you to do some examples on that from exercise 4J. But actually, we're going to use it for another example. So example 2, and in this example, it's going to be a fractional function. So find the gradient function. Just change my language up a bit here. Gradient function for y equals x squared plus 1 over x plus 1. I think that was what I was talking about up there, right? We will use the quotient rule for this, but I'm going to use a product rule first, because actually you can use the product rule for all quotient rule questions. You don't ever actually have to use a quotient rule, but it is easier, and I'm sure you'll find that is the case. So how could we use a product rule here? Well, we can rewrite this as x squared plus 1 by x plus 1 to the minus 1. So now we've got two functions, u and v, u being x squared plus 1, v being x plus 1 to the minus 1. Now it might just be worth our while ducking over to the side here and finding out what v dash is. Be minus 1 x plus 1 to the minus 2. Right, so that's minus 1 over x plus 1 squared. Right, that's useful to know when we do our product rule. So u by v dash, x squared plus 1 by v dash. Now v dash is here, all right, by minus 1 over x plus 1 squared. All right, that's u v dash. Now it's v 1 over x plus 1 by u dash, which is 2x. Okay, let's do a bit of simplifying here. Minus x squared plus 1 over x plus 1 squared. What's this? That's plus 2x over x plus 1. Now minus x squared minus 1. Now this 2x is, I'm going to get a common denominator here, so it's going to be plus 2x by x plus 1 over x plus 1 squared. So we end up with minus x squared minus 1 plus 2x squared plus 2x over x plus 1 squared. So we end up with x squared plus 2x minus 1 over x plus 1 squared. You can see a fair bit of algebra there. I'd already derived it at this stage here. Right, this was, I should have written dy dx here, because this was equal to y. This is my dy dx because I've already applied the product rule at this stage. So 1, 2, 3, 4 steps later, I arrive at the simplified gradient function. Now that's just using the product rule, bringing the x plus 1 out. And as I said, you can always do that. However, the quotient rule is going to make life easier for us. Now the quotient rule takes a function u over v, so y equals u over v, and derives it to this v u dash minus u v dash over v squared. Okay, so now my u is x squared plus 1. All right, so therefore for y equals x squared plus 1, is that right? Over x plus 1. I can do better than that. X squared plus 1 over x plus 1. So my u here is x squared plus 1, so that's my u. X plus 1 is my v. So dy dx is equal to v u dash, so that's by 2x, minus, so messy, sorry. V is x plus 1 by u dash, which is 2x, minus u x squared plus 1 by v dash, which is just 1, over v squared, x plus 1 squared. You'll notice that this is much easier to simplify. This is 2x squared plus 2x. This is minus x squared minus 1 over x plus 1 squared. And we end up with x squared plus 2x minus 1 over x plus 1 all squared. X squared plus 2x minus 1 over x plus 1 all squared. Same, but probably just a little bit easier. So use of the quotient rule is going to be really useful. So now let's get some practice. Exercise 4J and 4K. and I'll see you in class.